Hello everyone, and welcome to this session. Today, I will present you a use case of OCI registry that goes beyond the container images. I will explore a journey starting from GitOps to RegistryOps. So before that, I will begin by setting the stage with an overview of supply chains, starting from push and pull mode, followed by the GitOps principle. Then I will present the journey to RegistryOps from images to artifacts, then how to integrate these OCI artifacts in your supply chain, and then how to secure your supply chain using these OCI artifacts. But before that, let me briefly introduce myself. I'm Stefan Estegracias. You can contact me at Estegra handle on every social networks. And basically, I'm acting as a cloud-native innovation lead at ITQ, a European consulting company focused on multi-cloud solutions. That means that it's allowing me to connect people, organizations, and platforms to bridge the gap between the cloud-native technologies and the company strategy. Additionally, in the community side, I'm proud to serve as a community ambassador of the CNCF, advocating for the broader adoption of cloud-native technology first, and then contributing for the growth of our community. So let's begin with a short introduction or reminder for those about the supply chain that were in push mode. So let's start with a typical CI pipeline. The developer developed their code, push to Git, creating a trigger for the pipeline, the CI pipeline that build, scan, and push the image to OCI registry, and then build and push a dedicated Helm chart to chart repository. So this is a basic CI pipeline for the developer. But before pushing the application on Kubernetes, usually there is a platform team that creates platform configuration, push this platform configuration into Git, and then what happens most of the time in push mode, so we push the configuration to the Kubernetes cluster, a CD pipeline is triggered, and basically this CD pipeline will launch command like kubectl or Helm install, so we pull the Helm chart locally and push the resulting configuration to the Kubernetes cluster. So nothing fancy here, and the Kubernetes platform will pull the image afterwards to apply the required configuration. Then the application configuration is managed on the side project, so application definition repository. The application definition as well trigger a CD pipeline. The CD pipeline is as well calling some command like kubectl or Helm install command. The Helm is pulled from the local repository, and the resulting configuration is pushed to the Kubernetes cluster. And then the Kubernetes pull the image from the local repository to get the application deployed on the platform. So this is the usual way of managing push mode. So in that situations, with pull mode, the supply chain, you have the credentials here. So you can see how the credentials are spread around multiple users and multiple workflows. And these permissions are managed to access multiple services, OCI registries, chart repositories, Kubernetes platforms, etc. So how to reduce this spreading? By using pull mode. So the usual pull mode could be defined like this. So remember, we start with the same CI pipeline here. So before pushing the application on the Kubernetes platform, the platform team creates the platform configuration as well. But here, instead of pushing the configuration to the cluster, we install an agent on the Kubernetes clusters to pull the configuration from Git. So here, the relationship is reversed, and the steps afterwards are the same, except that all the tasks that were managed by the CD task are now managed by the pull agent on the Kubernetes side. So the chart is retrieved from the registries, and the dedicated image is pulled as well from the registries. So continue on the workflow. The application definition as well is pushed to Git, and the pull agents will pull as well this configuration and deploy the application as before. So no change here concerning the application of the application on the cluster, but here is the pull agent that is responsible of this. And you see here the permissions are now more centralized around the Kubernetes platform, and especially around the pool agent. But here, just before the solution, so here you see the difference between push and pull mode. So push, you're pushing the configuration from the CD pipeline, so you need to have access to the Kubernetes platform to do so. And in pull mode is the pull agent inside the Kubernetes cluster that need to have access to the Git repository. So we reverse the responsibility between these two actors, and you see the CD pipeline is replaced by the task managed by the pull agent. To add more than just pull mode, there is a GitOps that standardizes this practice, but not only this practice, but as well some more practices to be applied on the systematic approach. Let's see this principle defined here by OpenGitOps. So OpenGitOps is a CNCF working group, and they define GitOps as such way. So first principle of GitOps is expressing the desired state declaratively. In other words, the desired state is defined by a declarative configuration files, a language. Then the next principle of GitOps is storing the desired state. So this means two things. First, immutability. So when you store the data inside the desired state store, it cannot be updated. And versioning with the complete history. So that fits quite well with Git server. And then the following principle for GitOps involves the automation of pulling from a software agent. So exactly what we saw before with the pull agent on the Kubernetes cluster. And the last, but not least, principle for GitOps is to have these agents continuously observing the actual state and making ongoing attempt to apply this desired state into the platform. So it's the common operator practice with the control loop with continuous reconciliation. So now let's pick up from where we left off from the supply chain in pull mode. You see the pull agent here is replaced by a GitOps operator. It could be whatever GitOps operator with some Kubernetes operator, Argo CD, Flux CD, or Rancher Fleet is the tools I'm commonly used for the deployment of our platform for our customer. In the next slide, I will focus on how we will use Flux CD to replace Git repository by OCI repository. So when GitOps appeared, so Git was the de facto desired state store, but this desired state store can be whatever that could apply to the GitOps principle. So it could be something else. So you guess what it is because it was on the title of the presentation. But why Git is not the best solution, in my opinion, for a desired state store? First is some scalability challenge. As the repository grows, the operations such as cloning, fetching, diff, branch, etc., can become slower and consume a lot of resources in the pull agent, so in the Git operator. And Git servers are so difficult to scale. Then secret management is something difficult to manage on Git itself, so you need to have an extra tools on top of Git to manage secrets. And then, because you can have as well privileged escalation on Git that can occur, so the Git operator can get access on sensitive source code or can manipulate this source code as well. So I prefer to have a separation of concern between the producer and the consumer of the data. So to go over this challenge, you can use OCI registry to be used at the desired state for GitOps. So let's see how. But first, before going through how to replace Git server with OCI repository, let's see what is OCI registry and what are the registry meaning for the OCI specification. So OCI specifications are defined in three main specifications. The first, the runtime specifications, define the environment where container is running. So we won't see this today, but the next two will focus on them. So image, the image specification defines how container images are organized. And then the last one, the distribution specification, define how to serve these images using a registry, OCI registry. So these two, image and distribution spec, have been updated a few months ago. You see the date here in February. And the main updates were add the content else, anything else can be, anything can be pushed on OCI registry, not only images. So I will name them artifacts in the next slides. And you can have relationship between components inside the same repository, and we will see in the next slide how it is managed. So the registry, what is the registry? Basically, a registry is a service that implements the required HTTP API endpoint to push and pull image from and to. Then, here, you have an URL for a registry. This URL is based on multiple parts. So the first part, so this URL is basically used by a random registry client. It could be whatever tools you use to push and pull images from your registry. And the first part is the registry itself. So here is registry my lab. Then you have a repository. So the repository is a collection of related images of different versions or stored within the same repository. And this represents a namespace for grouping images together. And you will see later that will as well group something else. So then the reference afterwards is a generic pointer to an image. And this reference could be a tag for us, human, to understand what is behind this tag. So here, 1.29.2, or for immutability and for unicity and verification, you have a hash. Here, this is named digest, so it's a unique hash for the image content. Both can be used at the same time. So the tag for human and digest for unicity. But in that case, only the digest is taking care, sticking to by the registry client to push to the registry server. So the notation with both is only for humans to understand that this hash means this version. Then registry implements more, so image manifest, that is the metadata of the image, plus image configuration, and as well the content of the image that is stored in blob and layers. All these concepts I showed you here works for images since the beginning of OCI distribution and images specifications, but for the latest one, it applies as well for OCI artifacts. So this OCI artifact use the same image manifest to reference the metadata of the artifacts and use the layer blobs to store the content of this artifact. So first kind of artifact, so it was used for a long time, is stored on the same repository, but before this specification, it was stored with a well-known tag, but here you will see that is not anymore the case. We'll see later in the presentation. So it can be attestation, signatures, or software bill of materials that can be stored in parallel with your image repository. Then another method relies on putting your content on another repository. Such tools like Mchart can store the Mchart into the OCI registry. OCI repository configuration from Flux CD, for instance, or Kubernetes policy, or whatsoever you can put on repository that is not images. And to push whatever content on registry, you can use a tool named ORAS. So these tools can push whatever content you want into your OCI registry. And this ORAS name means OCI registry as storage. So OCI registry can be used for the purpose of GitOps as a desired state store, because it's easier to scale compared to Git server. It's more granular for the permission to push, pull, and pull from given artifacts. And then you can store any content. So especially the Kubernetes manifest that will be pulled from the GitOps operator and the Helm chart as well. So we see now GitOps pipeline, and now we will replace in the supply chain the content that were stored in multiple places into OCI registry. So let's pick up from where we left off from the supply chain in GitOps mode. So remember, the Argo CD, Flux CD, or Rancher Fleet GitOps operator is implemented in the platform to pull the configuration from everywhere, from the Git server, and chart repository and OCI registries. So let's move first the Helm chart. So Helm implement OCI registry since version 3.8.0. And the implementation they did at that time is compliant with the new specification. So the usual command you use to fetch a Helm chart from the HTTP endpoint. So here is Cert Manager. So it's mostly the first package I installed on the Kubernetes platform. Then you get the tarball with the Helm chart inside. And this, you just have to use mpush and the name of the tarball and the OCI URL to push the content inside the OCI URL, OCI registry. And after pushing this into the OCI registry, you get the tag and the digest from the OCI registry you use. So it's quite straightforward for Helm chart. So then, if you want to install from the OCI registry, you can use the usual command you use usually to deploy Helm chart, but you just have to replace here, instead of the URL or the name of the chart, you put directly the OCI URL. So, previous GitOps supply chain can be updated easily. You just have to move the content from container image and Helm chart into OCI registry. Then, for the GitOps operator, we'll transition from GitOps to RegistryOps using Flux CD. With Flux, we collect the manifest, Kubernetes manifest you would like to push into to use in the configuration in a dedicated folders. We use Flux push artifacts with the OCI URL and the path where are stored all the Flux configuration. And Flux will push it to the OCI registry and get the digest of it afterwards. So afterwards, to use this new OCI configuration, you have to update your Flux configuration by updating Git repository by OCI repository and replace the spec by the URL of the OCI plus the version you pushed. So now the GitOps supply chain can be transitioned to RegistryOps. We have the same pipeline as before for the platform configuration, but instead of having a direct consumption from the Kubernetes platforms, here we can have a similar pipeline of the developers to have a CI to build and scan the configuration, the platform configuration, create the platform artifact, and push it to OCI registry. And the steps afterwards are similar to the one before, but except of pulling information, configuration from Git server, you pull from OCI registry, and the steps afterwards are exactly the same. Then you can do exactly the same for the application configuration to push the application definition artifact into OCI registry. So everything is pulled from the OCI registry, and everything is applied as before using Flux CD with OCI registry as a single source. So here you see the credentials and required permissions are now focused on a single service that is OCI registry. So for security, it's very convenient to manage only one point of failure to manage the security access and permissions. And OCI registry can be as well scaled easily when the workload grows. So But I put here RegistryOps, but it's still GitOps at the end. You only replace Git servers by OCI registry, so it's still GitOps in a way of Open GitOps define it. You just replace the desired state store Git server by OCI registry. So now, because we use OCI registry, we can put on top of this a layer of security by signing all the artifacts inside the OCI registry in the producer area, and verify them before applying in the consumer part, so in the Kubernetes cluster. So let's see how with this next slides. So here is exactly the same slide we left off from the RegistryOps before, and we will just add a new task here in the CI pipeline to add signatures on container image and Helm charts. So in the next slide, I will use notation CLI from the Notary project to sign images and Helm charts. Let's see how. So using notation CLI. So here I'm using some variables to ease the command line afterwards. So the image, the tag, and the digest. So the digest, I collect it using regctl tools. That is a very convenient tools around OCI registry. If you don't know it, please have a look. It's very nice tools. And get this digest. And then to sign this image, I just have to use notation sign. Notation sign plus with the name of the image and this digest. Use the digest because digest is immutable compared to tag. And what notation sign do? It will push the related, first it will sign the image, then push the related image to the OCI registry and got the tag and the digest of this image, these signatures afterwards. And the third action that notation sign will do is as well attach these signatures to the image. So this attachment, as I explained during the presentation of OCI specification, is a new specification in OCI that can connect whatever object in the same repository to link them by a relationship. And this relationship is named referrers in the specifications. To verify this relationship, we can use a notation ls command to read on the OCI registry what is the relationship between these images and other objects in the repository. So here you see, first it's a tree, similar as the tree command you can have on Linux. So on top you have the image itself, the one we sign, plus the type of object that is connected, related, or refer to this image. So here is notary signatures, and here the notary, the signature object with its digest. So you can use another command to see that is an interoperable configuration of attachment. Before this implementation, the tools that sign the images used a well-known tag. So this tag should be known by every tool that use it. Now you don't need it at all. You just have to use an interoperable tools that knows how to implement OCI 1.10 specification. And without, as expected, we got exactly the same result from the previous command. So that means that OCI, the new specification of OCI, is interoperable with multiple tools that implement this specification. So no image are signed. So I put here a stample on the image, on the container image, because it's verified and is ready to be pushed to the OCI registry and ready for consumer to use. So let's move on the sign of the Helm chart. So it's quite similar. So if you remember where we were on the push of the cert manager Helm chart on the OCI registry, we collect the chart name and the digest and use notation sign as the image. So everything is artifact on the OCI registry, whatever the format, it could be image or chart, you use notation sign, you got the digest of the chart, of the signatures, and if we use notation ls, as before, you got the same result with the tree, the chart, the signature attached to the chart. So notation sign, remember, he first signed the chart, push the signature to the same repository as the chart, and attach these signatures to the chart. And by using ORAS discover command as well, you can have the same result. So now we have both container images and mchart sign. So now we can pass to the platform configuration. So on the CI pipeline, we can use as well the task for signatures of the platform configuration. The same for the application configuration. So because here they are both the same workflow, I will show you only the application configuration. So remember, when you push this application configuration from a dedicated path on the Git server, on the Git repository, we got the URL of the given artifact that is pushed on OCI registry plus its digest. So if you can get it back using regctl as well command for the digest of the configuration, and use exactly the same command line, notation sign, to sign the Flux configuration, to push the signatures into the same repository as the configuration, and then attach these signatures to the Flux configuration. And as expected, with notation ls, we get the same result as before. So I didn't put here the ORAS discover because I guess you understand. So now we have everything in OCI format, signed, and on the OCI registry. So in the producer, as a producer, we produce artifacts that are stored in OCI and signed to be used afterwards. But now, how to verify these signatures before applying into the Kubernetes cluster? For images, you can use admission controller. So you can implement either your own, so do it yourself, implement your own admission controller that will verify images that are pulled from the OCI registry, or you can use some admission controller that exists in the CNCF, so like OPA Gatekeeper, using a companion tools named Ratify Verifier, or you can use Kyverno policy with the verify images rule, or you can use as well Kubvarden with the verify image signatures policy. So use one of them to do the verification. Then for the mchart and the Flux configuration, you can use Flux itself. So let's see how to do it with Flux. So Flux can verify the artifact before applying into the Kubernetes cluster. So before that, we need to create a dedicated secret that contains the configuration and notation we use in the producer environment. So here we need a trust policy and the root CA that has been used during the notation creation. And then use this configuration in your Helm release. So this is the Flux configuration to deploy a Helm chart. So here we just have to update this Helm release manifest by adding a verify block pointing the notation configuration we just created before. For the Flux configurations, so the OCI repository objects, do the same by adding a verify block for it. So now we have all the images signed and stored on the OCI registry, verified on the Kubernetes cluster before consumption, either for the image, the admission controller, or the Flux verify block for the mchart and the configuration. And you see, as a result, OCI registry is now a single, scalable, and secure source of storage for your supply chain. So let's wrap up what we see today. That in these sessions, I showed you that you can push whatever you want in OCI registry since the release of OCI distribution and image specification from last February. So you can push signatures, as I show you here, but I recommend you as well to put some software bill of material and attestation. You can push mchart, Flux configuration, or any content using ORAS command line. Then RegistryOps is still GitOps at the end. You just had replaced the Git server desire state store with OCI registry. And then OCI registry is a single scalable, and secure source of storage, where signatures can be pushed and pulled to be verified before using the attached image of Helm chart or Flux configuration. So thank you. If you have any question, I will be around. And if you would like to continue the discussion as well, you can contact me using that code. I will be available for further discussion if you want. I would like to thank you, the organizer and the sponsor for this event, and thank you very much for your attention. So no time for a question. If someone have a question, yes, please.
Thank you. This specification that is released in February 15th, is it available in the popular cloud container registries?
Good question. So here I don't say, but repeat the question. The question is this specification available on the public cloud? So for this presentation, I did a lab with Zot project. So it's a CNCF project that implements a registry. And I've seen last week that Azure OCI registry is compliant with Dot version as well. But for others, I don't know. But it will be soon, because all the tools are more and more implementing these new specifications.
OK, thank you.
Yeah, the next question is, can we implement this with Argo CD as well?
So the question is, can we implement this as well with Argo CD?
Yeah.
So the answer is, I don't know, because I mainly use Flux and RegistryOps for now. I know that RegistryOps is implementing some stuff around OCI registry, but it's not available right now. I know that Argo CD is mainly focused on Git server. So the architecture of Argo CD is managed around Git server. So I don't know if it's already available, but it will be more difficult than other tools because it's more centric on the Git server right now. But probably will be implemented as well. I don't know.
All right. And the next question is that in addition to the images and the artifacts, there are also the configurations
yes.
to deployments, right? For example, if you have a different version with different customers, and where do we manage them in this approach? Let's say you have secrets and credentials for different customers. Would you put that?
So the question is, where do you put secrets of the configuration you manage on this solution?
Those variables, for example, those data goes to the apps themselves.
Yes.
Right? Is it?
So there are many solutions for that. Either you can push everything as one-on-one between the configuration you have. You don't have the screen anymore. But if you remember on the pipeline, I add a step before the OCI registry. Usually, is the GitOps operator that collects the information from the Git server, and the Git operator manage to update some variables with some tricks on the Git operators, with variable replacement, something like that, or as well some security plugins. Here, you can put more in the CI pipeline to avoid these tasks to be managed by the GitOps operator. If you have a huge amount of clusters and huge amount of resources, sometimes the GitOps operator consumes resources to manage this replacement or customization, etc. But here, if you want, you can shift shift left to the CI pipeline if you want. And you can use whatever you want as secret management. You can use secrets operations or etc. So it's the gong for the last question. It was the last question. Thank you very much for your attention and questions, and we can continue discussion afterwards if you want.